Okay, gang, here we go. This is section 3.3, second to last section of the semester. And after this, we're going to spend the rest of the time reviewing before the final. Okay, here we go. 3 things to learn today. Number 1, how to learn the rules of logarithms. Number 2, learn the change of base formula and how to apply it. And then number 3, apply logarithms to growth and decay. This last one you'll see is actually very similar to the compound interest formula that we learned previously. Okay, let's do it. Number 1, rules of logarithm. And I posted a video to our discussion, but also I think I mentioned this before. But the thing about logs is what they do is they take multiplication, like m times log of m times n, and changes it to addition log of m plus log of n. And why is that? Because, well, if you think about the definition, it comes from the exponents, right? When you multiply two things with the same base, you just add their exponents. So similar idea there. Quotient rule, same thing in the backwards direction, right? If you take m divided by n, the log of that is the log of m minus the log of n. So we go from multiplication to addition, and we go from division to subtraction. See that? And then you have the usual restrictions. M and n, they cannot be 0. They got to be bigger. Why is that? Because there's no way to get some base to no power is ever going to equal anything that's 0 or negative. Okay, the power rule. The power rule, kind of analogous if you think about it, right? If we're going from multiplication to addition, we're going from division to subtraction, then we go from power to multiplication. Now this power over here, you see the exponent? Let's do a different color here. This exponent is the thing that gets pulled to the front as a multiplier. So log of m to the n is n times log of m. So that exponent comes out here as just a regular multiplication. Okay, that's it. So those are the rules. Simple enough. And it's only 3. So, you're going to take a problem and then you're going to basically apply one of those 3 things. Those 3 rules. And we're going to use those rules to simplify logs or to, like in the questions numbers 1 through 9, rewrite as a sum or difference. All right. See how far we can get in this first video. 18 questions seems like a lot, but I think some of these should go relatively quick. So let's just jump into it. Okay, starting with number 1. So I got the log base 2 of x, y, z, right? So it's to write as sums or differences. You got 3 things multiplied. Remember our rule says it's multiply. You can change that to addition. Same base 2, log of x plus log of y plus log of z. Keep the same base of 2. Yeah. And let's just keep that there and move on. Number 2, log of 5 over 3x. Okay, let's do this in 2 steps. First step, you see there's a division, right? So it's going to be log, and it doesn't say the base, so we assume this is the common base of 10, but shorthand notation lets us just write log. That's log of base 10 of 5 minus log of 3x, and then that's looking good. But then you notice, oh look, this guy can be rewritten as a multiplication as well, because I got a 3 and I got an x, right? So, okay, be careful here though, guys, because you're subtracting this whole thing, right? What is that whole thing? If I'm going to split it up into 2, then I should make sure that this whole entity is treated as one big entity. So what I mean is that when I split this to log of 3 plus log of x, and I'm able to do that because multiplication becomes addition, right? Well, I'm subtracting that whole thing. So this one, this negative, if I was to, simplify, it's going to distribute. So it's going to give me this final result of log of 5 minus log of 3, minus log of x. There you go. Okay, so that's 1 and 2. Let's do one more. without erasing. Here I've got log of 3 square root of x. Okay. First thing I see, multiplication happening, right? I'm going to switch that to summation. That's going to be log of 3 plus log of square root of x. But you know, square root of x, that's actually just a power. And what power is that? I'm going to rewrite it as a power here. That's really x to the 1/2 power, right? Right, and there's 3 things that we could do, right? It's x to the 1/2 power. There's 3 things that we could do, right? Remember, if we have multiplication, change to addition, division, change to subtraction. Here I have an exponent, which change that to multiplication. So that's going to be log of 3 plus 1/2 log of x. And so you see, as we do these things, if we have something that looks like a complicated log, we can really break it down to little simple, very simple logs, right? You have these kind of complex looking logarithmic expressions, and then we can just break them out to sum and differences of very simple logarithmic expressions. So that's a nice feature of logs. I don't know, I'm not sure which video, I kind of forget which video. I watched a bunch of log videos kind of looking for one that I thought would be useful for you to look over in. I forget which one I ended up posting, but one of the videos I posted, or I read, I mean watched, one of the videos I watched kind of talked about abacuses, or how they used to have like, they used to use logs to help do calculations because of the same feature they were just talking about. Okay, here we have the natural log of 4a over 3b. Let's split up into the differences first. That's ln of 4a minus ln of 3b. And then same thing as saying before, right? This is natural log of 4 plus natural log of, you know what? I forgot. I was supposed to write cursive L, yeah, for natural logs, so it doesn't look like one n. So ln of 4 plus, this is plus ln of a, and then minus this entity here. I didn't need parentheses here because it's just addition anyway. But this is going to be ln of 3 plus ln of b. So that's ln of 4 plus ln of a minus ln of 3 minus ln of b. Okay, that's 4. Okay, 5. I got the natural log of this, okay, this big ugly looking thing, cube root of xy over t to the 4/3. But don't worry, just do one step at a time. It's gonna be okay. Here I have something divided by something. So my first thought, let's just split that in 2. And I'm gonna rewrite this as to the 1/3 power. So I have a division, that means it's changing to a subtraction, right? ln of t to the 4/3 power. And now I'll take care of those powers by just bringing them right to the front. So that's the 1/3 ln of xy minus 4/3 ln of t. Okay, now this piece, I got some multiplication going. So I'm going to change that to addition. So I got 1/3 ln of x plus 1/3 ln of y minus 4/3 ln of t. And I got nice simple logs, right, in my final result. Very nice. Okay. That's 4 and 5 done. Yeah, and you know, at this pace, what I'm thinking would make the most sense probably is for me to just do these first 9 questions in this video, and then in the next video, we'll do the next 9. Keep it nice and simple. All right, number 6. I've got log base 4 of 3x root y. It's looking like it's this big ugly thing. But again, don't worry. Just do one little step at a time. This is log base 4 of the top minus log base 4 of the bottom. Yeah. Okay, let's let's take a moment to just rewrite with powers instead of radicals. To the 1/3. So cube root is just a third power, yeah? Okay. Now let's take care of the multiplication aspect. So I've got log base 4 of 3 plus log base 4 of x plus log base 4 of y to the 1/2 power. And then I got minus log base 4 of, okay, should I pull that power down? Right now I'm only addressing the multiplication. So I'm just going to rewrite this thing. Okay, now I'm going to address the exponents here. There's one there and there's one there. So that's log base 4 of 3 plus log base 4 of x plus log base, bring the exponent. Exponent comes to the front. So it's 1/2 log base 4 of y minus 1/3 log base 4 of x minus 1. And the only thing that looks like it's not very simple is this x minus 1, but there's nothing we can do with subtraction because we can go from multiplication to addition, we can go from division to subtraction, we can go from exponents to multiplication, but we can't do anything with addition or subtraction. Those are already stuck where they are within a log. Okay, so that was 6. Oh yeah, these things looking uglier and uglier, yeah. But like I said, don't worry. It's just more steps, but really it's like kind of all the same thing. Okay, number 7. Got the natural log of x root x minus 1 over x squared plus 2. Okay, first thing, take care of that subtraction. It's going to be pretty much our standard first step whenever you have fractions. So ln of the top minus ln of the bottom. And then there's actually not that much more to do here. Here I'm going to rewrite this as x and then x minus 1 to the 1/2. This ln x squared plus 2, that guy's just going to stay stuck. Okay, this is going to be, I'm going to take care of the multiplication now. So it's going to be ln x plus ln of, can I do 2 steps in one, guys? So I have this power, right? I'm going to just pull it down as I split it up. So what do I mean? You know, if you don't like that, then you can separate these 2 steps. But this is really just half ln of x minus 1. Here I got minus ln of x squared plus 2, and that guy's just stuck. And for the first time, I finished it, but I didn't write the answer in red, so let's box it in red instead. Okay, there you go. No problems, right? No biggie, no biggie. Okay, number 8. Okay, now we got this big, ugly looking thing. Okay, I'm gonna, for the sake of space, and because I don't want to write this out, I'm gonna try to write it out as few times as I can because it's long. I'm just gonna do my first step and go ahead and do this division part. So I'm gonna do ln of the top minus ln of the bottom. Okay, so it's ln of square root of x minus 2 times the cube root of x plus 5 minus ln of the bottom, which is x plus 4 squared, x minus 3 to the 4th. And you know what, honestly, this is actually not that bad because you got these minus pluses. These are just going to stay put. No big deal. Okay, so let's take care of the multiplication part now. And at the same time, let's also rewrite these with powers instead of roots. So that's going to be natural log of x minus 2 to the 1/2 power plus natural log of x plus 5 to the 1/3 power. Okay, now I'm gonna subtract, but remember I'm subtracting this whole big thing. So I'm gonna actually change the color here. This whole big thing, it should be in its own set of parentheses right now, because I'm gonna do some addition, but I can't forget that this subtraction is applied to that overall thing. So it's gonna be ln of x plus 4 squared plus ln of x minus 3 fourth. Yeah. Okay, notice the way I have it written here. This square is only applied to the x plus 4. But if you want to be extra explicit, you can add an extra set of parentheses. It means the same thing here, but this just might help you to keep things straight. That's happening. ln is happening after this squaring is occurring. Because the squaring is happening inside the ln function, that's what allows us to take that power to the front. So right now we're going to take care of all these powers. I got 4 of them. Let's go ahead and do that. Oops. Okay, so I've got ln of, 1/2 ln of x minus 2 plus 1/3 ln of x plus 5 minus, okay, this guy's still chopped in the parentheses, so let's do the parentheses last. This is 2 ln of x plus 4 plus 4 ln of x minus 3. Okay, none of these guys match up, yeah, so I can't combine any of those terms. Maybe if I had an x minus 2 and an x minus 2 there, both the same, then I could have done some, combination, but they're all different, so they're all gonna stay separate. Okay, it's half ln of x minus 2, just copying this part down, 1/3 ln of x plus 5, and now let's take care of this minus. This is gonna be minus 2 ln of x plus 4, and then this is gonna be minus that, right? So minus 4 ln of x minus 3. Okay, and that was number 8. There's your answer. This is the sum of all these individual simple parts. I kind of like the way it comes out. Like when I see that big ln of that big ugly conglomeration amalgamation on the inside, it seems like it's really complex. But then you split it up into these nice little, very simple ln functions or natural log functions, whatever it is. It's kind of a nice feeling there. Okay, so same thing I'm going to do here, guys. I'm going to take the top minus the bottom, ln in front of each. So it's going to be, this is number 9. I haven't been writing the numbers, yeah, sorry. It's ln of top, which is x cubed, 3x plus 1 to the 4th, minus ln of the bottom, which is x minus 8 cubed times 2x plus 5 cubed. Okay. Let's do the multiplication. So this is ln of x cubed plus ln of 3x plus 1 to the 4th. Yeah. And then minus ln of x minus 8 cubed. And then here's where, again, you want to pay attention. You're minusing this whole thing, right? So parentheses here. Or maybe even if you want brackets. Because brackets mean the same thing as parentheses, but just visually maybe easier to see. Okay, plus ln of 2x plus 5 cubed. Bracket. All right, now let's take care of the powers. I don't know why I've been highlighting powers for some reason when I do this, and I haven't really been doing that with the other. Oh, yeah, it kind of makes sense because it's easy to highlight. Okay, bad choice colors. That, and that. Okay, so that's 3 ln of x plus 4 ln of 3x plus 1. Okay, you know what? I'm going to do 2 steps at once here, guys. I'm going to take care of this minus and go ahead and distribute it as I bring the power down. This is minus 3 ln of x minus 8. This is going to be minus 3 ln of 2x plus 5. Yeah. And let's see, is there anything else I can do? Do I see any multiplication or division inside these LNs? Well, okay, I see 3 being multiplied by an x, but I also have the plus 1, so I can't split it up into a product, right? It's not a product, it's really the sum of two things. So no, the answer is no. I reached the end of what I can do. And so, box it in red, there it is. Okay, see you in the next video.